All right, greetings everyone. The purpose of this video is to go over some of the prereq material, some of the review material we need to have in our brains prior to starting section 1.2. So as before, I won't go through all of the problems on this handout here, but I will go through some of the most important ones. And also, there will be a copy of this handout available on WAMAP if you would like a copy of it yourself. Okay, so the first question here asks us to use this inequality here to complete the problems below. So this inequality says negative 2x minus 3. And then we have to think about, what does this inequality symbol here mean if the arrow on the inequality is pointing to the left, and or I also like to think of it as an alligator mouth. And if I draw a bigger picture of it here, see the alligator mouth looks like this. If I add teeth to it, hopefully now you can see that it's a mouth. And I always think that the alligator mouth eats the bigger side. So since the mouth is opening to the right, that would mean the stuff on the left is less than. So negative 2x minus 3 is less than 5. We're going to use that to complete the problems below. Okay, and the first thing we're asked to do is to solve this inequality. So when we solve an inequality, we do it very similar to the way that we solve an equation. So I'll set this up as negative 2x minus 3 less than 5. So what we need to do is isolate our variable there. So we'll add 3 to both sides. So we end up with then negative 2x is less than 8. And to isolate the x there, we need to divide by the negative 2 since it's right next to it, meaning it's being multiplied. Okay, and that will give us x here on the left because these 2's cancel. 8 divided by negative 2 gives us negative 4. And then one additional thing here, because we divided by a negative, and anytime you divide by a negative on both sides of an inequality or multiply by a negative on all sides of an inequality, you have to switch the sign of the inequality sign. So here we have a less than, but since we divided by a negative, then we're going to make this a greater than symbol. Okay, and there is our solution for the inequality. X is greater than negative 4. All right, now we're going to then, in part B, graph the solution for this. Okay, so we have a number line here. We need to graph it. The way that we can do that, first of all, is looking at inequality. The only number I see here is negative 4. So I'm going to start at negative 4 with some sort of a dot. And in this case, it will be an open dot because if I look at my inequality here, it's just a greater than. It's not greater than or equal to or less than or equal to. It's just greater than. So that tells us we'll have an open dot. And then because it says x is greater than negative 4, that means our solution set is all numbers bigger than negative 4. So what I'm going to do then is put an arrow here going to the right like that. Okay, and so there is our solution as a graph. Okay, so again, open dot at negative 4 going to the right. And what that tells us, in case you're wondering, is that any of these numbers that are covered by the arrows, so negative 3, 0, 4, 1/2, negative 1.5, any of those can be plugged into this equation up here, and they will give us a true statement. Okay, so we will get, if we plug in, like say, negative 3 for x over here, we will get something that is less than 5. All right, the last part then is to write our answer in interval notation. And interval notation, the way it works is you generally have, you're going from one number to another. So you have something written as number, comma, number. And then on the outside of those numbers, there's either parentheses or brackets. Sometimes it might look like that. Sometimes it might look like this. Sometimes both of these things may be the same thing. You may have both parentheses on each side, both brackets on each side. It all depends on what you see in your solution. And one way that I like to do this is I like to look at my graph and read left to right to help me figure out what goes in my interval notation. So when I read left to right, notice that even though there's an open dot at -4, that's the first number we start at. So from my interval notation, I'll have -4, comma, and then we have the arrow going to the right. We want to figure out what number it's going to. Well, it goes on forever and ever. That's what the arrow means. It never stops at any number. So it will be the number way out there that it's getting closer and closer to. Right, that would be positive infinity. Okay, the next thing is to determine whether we have parentheses or brackets around these. And we use parentheses when a number is included or when there's a closed dot. And we use a bracket. Sorry, I think I said that wrong. We use a bracket when a number is included or there's a closed dot. We use a parenthesis when there's an open dot, meaning the number is not included or not part of the solution set. So here, because -4, we have an open dot at that. That means -4 is not included in the solution set. If we plugged in -4 up here, it would not give us a true statement. So because the -4 is not included there, we're going to put a parenthesis around it. And then with infinities, we always put a parenthesis. They're always not included because infinities are something we get closer and closer to, but never actually reach. Okay, and that will be our solution there. So it's parenthesis, -4, comma, infinity, parenthesis. All right, let's move on then to the next one. And now we have what's called a compound inequality. And it's called a compound because, as you notice, there are multiple inequality symbols here. So we're asked to solve this one, and I'm going to do it using that there. And when we solve this, what's important is we still need to isolate our variables, so our variables here on the inside. And in order to isolate it, when we have to subtract things or divide things or whatever, what's important is that we do it on all sides of the inequality. So notice in this case, there are 3 parts of this inequality. There's this one, and this one. So anything we do to one part, we have to do to the other parts. Okay, so let's begin by isolating the x there in the middle. The first thing we'll do, subtract 5 from all sides. So we'll subtract it from the 17, and we'll subtract it from the -1. And we do that, -1 minus 5 gives us -6, less than or equal to 3x, less than 17 minus 5 is 12. And then we isolate the x there, divided by 3, and again we divide everything by 3. And so what we end up with there is -6 divided by 3 is -2, less than or equal to. In the middle again, 3's cancel out. So we just have an x and then less than 4. Okay, so we have -2, less than or equal to x, less than 4 as our solution set there, our inequality solution. All right, for the number line solution to this, with compound inequalities, it's often a little bit more straightforward than the other ones because we already have the 2 numbers or 2 endpoints there. So notice we have a -2 and a 4. And then we want to look at whether or not those are going to be open or closed dots. And notice here with the -2, we have that equal to sign underneath there. So that tells us this here will be a closed dot. With the 4, that's going to be an open dot. And then we just have to connect the 2. And the 4 will be an open dot because notice that here there's just a less than sign, no less than or equal to. So our solution set as a graph looks like -2 with a closed dot, up to 4 with an open dot, and then connect in between. Another nice thing about compound inequalities is that writing the interval notation is often a bit more straightforward as well, because in this case we have number and another number, so that tells us what goes in the in interval notation. So we'll start with the left number, -2, the right number then, which is 4. And then -2, notice there's a closed dot, so that means it is included in the solution set, so we'll put a bracket there. And with the 4, since it's open dot, we'll put a parenthesis. So our solution interval notation looks like bracket -2, comma, 4, parenthesis. Okay. All right. Moving right along then. As we get set up to talk about something called domain and range in section 1.2, we want to look at functions and think about what sorts of numbers are allowed to be in for the variables. And so let me explain more about what I mean by that. So when I look at this first function here, f of x equals 4 over x, well, notice I could plug in, say, x equals 1 here, right? And I would end up with 4 over 1, or f of 1 equals 4 over 1, which gives us 4, and that's okay. I could plug in x equals 2, and I could do f of 2 equals 4 over 2, and that'll give me 2, and that's okay. So those are things that x can be. But when we're thinking about all the different possibilities what x can be, it's often helpful to think about what x cannot be. So what if we tried to, say, put in x equals 0 here? Well, if we do that, we'd have f of 0 equals 4 over 0. And hopefully at this point some alarms start going off your head, right? Because here, 4 over 0 technically means 4 divided by 0. Is that allowed? No, it's not. Okay, so therefore we cannot have 0 as a value of x. Okay, so that would be something that x is not allowed to be here. All right, and if we think about it, there's really nothing else that x can't be, because it can be any number above 0, 1, 2, 10 billion, 1.2, 10 billion.1, any of those sorts of things. And it can also be any negative number, right? -1, -2, -1,000, -1.5, any of those. So the only thing x cannot be is 0. So now let's describe that in interval notation. And again, x can be anything except for 0. So to say what x can be, well, it can be any number as negative as we want. So in that case, we can say we can start at -infinity up to, but it cannot be 0, right? So I'll put a 0 there and an open parenthesis. Now I'm not going to -1 there because I can have things between -1 and 0, right? Like -0.5, -0.25, those sorts of things. I just can't have 0. I can have every little number up to 0. But then I can also have numbers bigger than 0, right? So how do we include that here? Well, again, we could start with 0 now. Okay, again with the parenthesis because it's not included, and then say go up to +infinity. And now each of these pieces here describes a part of what x can be. And so what we do to join them together is we put this u here, so that unions the two. So -infinity to 0, union 0 to infinity would describe what x can be in this function. Okay? All right, looking at a similar thing with b. I'm not going to go all the way through all of finding the interval notation here, but let's again focus on the denominator here to think about what t can be. In order to think about what it can be, we've got to think about what it can't be, right? And so in this case, t could be 0, right? Because we could do v of 0 equals 5 over 1 minus 0, which gives us 5 over 1, which is 5, and that's allowed, right? But so is there something else that t can't be? Well, again, because we have what's called a rational expression here, and it's called rational meaning because it looks like a ratio, kind of like a fraction. What is not allowed are things that make the denominator equal to 0. So basically, any value of t that would make 1 minus t equals 0. So what we can do to deal with that is set up an equation. 1 minus t equals 0. We can solve that by subtracting 1 from each side. -t equals -1 divided by -1. And so we would see here that what makes that equal to 0 is t equals 1, right? So that would be the only thing that cannot be in the domain or cannot be the values for t in this function. Okay, and so we'd write then some interval notation similar to what we did for the previous one. All right, one more example. Here we have some functions involving square roots. And just like below, we want to figure out what are the values the input variable can be. Now with the square root, right, the restrictions are about what can be under the square root. And we know that negative numbers are not allowed under square roots. Is 0 allowed? Can we take the square root of 0? Yes, we can. So it looks like for this first function, since it's just the square root of x, we could start at 0, because that is the lowest amount we can have. We can't have numbers below 0 because we can't have negatives. But then we can have any number bigger than that, right? So we can go from 0 all the way up to positive infinity. And so that would be our set of possible input values there. For the second one, the g of b equals 3 minus b. Well, again, underneath the root, we can't have anything below 0, right? We can have 0, but we can't have negative numbers. Now be careful. In this case, it doesn't mean that the variable can't be negative, right? Because notice if I do g of negative 1, that would give me square root of 3 minus negative 1, which the minus there will make a plus. So I'd have 3 plus 1, which is 4, and square root of 4 is 2, and that's all good. We didn't have any problems there. So it's not that the value of the variable can't be negative, it's the thing underneath the square root can't be negative, that 3 minus b. And in fact, 0 is the lowest it can be. It has to be 0 or anything bigger than 0. So to deal with that, to find the values that here that b can be, we're going to set up an inequality. So we'll do 3 minus b is greater than or equal to 0. And again, the reason for that is what's here, this expression 3 minus b, it's under the root, so it has to be 0 or bigger. So that's why we have written as greater than or equal to 0. We can solve this. Subtract 3 from both sides. So we'll end up with negative b greater than or equal to negative 3. Then we can divide by negative 1 on both sides to get rid of that negative b. Since we divided by a negative, recall that switches your inequality. So this will now become b is greater than or equal to 3. And then just as before, I'm not going to do right now, but we'd have to write that in interval notation. And sorry, I made a mistake there. That should not be greater than or equal to. That should be less than or equal to, because we have to switch there. So it should be b is less than or equal to 3. All right, that's all for now. Thanks for watching. I apologize. This video was a bit longer than I anticipated it to be, but we covered some good stuff here. Thanks again.